I'm Anil Kumar. Welcome to my series on vectors. We'll discuss scalar triple product. Let's begin with a very basic question, which is a true or false question. If scalar triple product A cross B dot C between three non-zero vectors A, B and C is 0, then the vectors are coplanar. Explain your answer. What do you think? Is it that all the three vectors should be coplanar when their scalar triple product is 0, always true? Let's think about it. Let us say they are coplanar, right? So let's say we have three vectors here. Let's place them besides one another, right? Let's say kind of like this. Let's say these are three coplanar vectors. Now if I do the cross product between, let's say, A and B, we get something which is perpendicular to this, right? And also to this. Now, if I do dot product with C, right? In that case, we do get 0. So in this case, we do see that if the vectors A, B and C are coplanar, then A cross B dot C will be equal to 0 is always true. Correct? That has to be true. Always true. But now there could be other conditions also. So what could be the other conditions when the scalar triple product is 0? Now think about vector A equals to vector B. So that is to say that if I have two vectors, let's say in my scenario, let me sketch this situation once again. Let's say this is a vector A and vector B is also in the same direction, right? They could be scalar multiple also, right? But they are in the same direction. In that case, what happens? Now, if I do cross product of these two vectors, that is to say, if I do the cross product of the vector A with B, and if they are collinear, that is going to be 0 vector also, and therefore the dot product will be 0. So in this case also we are going to have A cross B dot C equals to 0. So what we have to be careful is to note that the three vectors should not be collinear, right? So there is a very important word which is missing here, and which is they should be non-collinear. So if we are saying that we have three non-zero, non-collinear vectors, then this statement is always true. Otherwise not. Since this is missing, we'll say this statement is false. Correct? Because A and B could be collinear vectors. Even then, the scalar triple product will be 0. So make a note that for A cross B dot C equals to 0, meaning as coplanar, we should also note that A, B, C are not collinear, right? Only then we can conclude that they are coplanar, because if A equals to B, or if A or B are scalar multiple of one another, they are in the same direction, in that case the cross product is going to be 0, and that will also lead to triple product as 0. Perfect. So I hope that makes sense, right? So the cross product could be a 0 vector if the two vectors are collinear, and therefore we have to include this condition when we are saying that scalar triple product being a 0 means that the three vectors are coplanar. So we should have two conditions here. One, of course, which is included, non-zero vectors. The second, non-collinear vectors. So I hope that makes sense. So that is a caution. Now with that in mind, let's take a few questions based on the application of scalar triple product.